Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter sets and relations. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, please install our Sapience Education application where we shall upload some important previous year previous year questions on every chapter of maths, um, which shall be obviously helpful for your exam. So here it is told that let A equals to 13469 and B equals to 245 8 10, and let R be a relation on the set A cross B such that R equals to A1 B1 A2 B2, such that so it means that A1 comma B1 is related to A2 comma B2 if A2 if A1 is less than or equal to B2 and B1 is less than or equal to A2, then the number of elements in the set R is yes, so here actually A1 should belong to A1 and A2 should belong to A, and B1 and B2 should belong to the set B. So therefore A1 can be 1 3 4 5 4 6 or 9. So now if A1 equals to 1, then B2 can be 2 4 5 8 10. It means there are 5 choices for B2. And if similarly A2 is 3, then B2 has 4 choices. Similarly, if A1 equals to 4, if A1 equals to 4, then B2 has B2 has 4 choices again. B2 has again 4 choices. And then if A1 is 6, then B2 has 2 choices. And if A1 is equal to 9, then B2 has only one choice, which is 10. So therefore, the number of pairs, the number of pairs of A1, B2, that will be is 4 plus 6 plus 9. No, sorry. 4 plus 2 plus 1 plus we have 4 plus 5, which is equal to 5 plus 4, 9 plus 1, 10, 16 choices. So there are 16 such pairs of A1, B2. And then for A2 and B1, B1 is less than A2, so B1, and for B1 equals to 2, if if B1 is 2, then A1 A2 has B1 should be less than A2, so B1 has 4 options. B1 has A1 has 4 choices, which are 3, 4, 6, and 9. Then if B1 is equal to 4, then A2 has 3 choices, which is 4, 6, and 9. And if B1 equals to 6, then A2 has 2 choices, which is 6 and 9. And if B1 equals to no, no, no. B1 cannot be 6, B1 can be 5. So B1 is 5, then also A2 has 2 choices. Then if B1 is 8, then A1, A2 has 1 choice. And also if B1 equals to 10, 2, 4, 5, 8, 10. Okay. If B1 is 10, then A2 has no choice. A2 has no choices. So therefore, the number of pairs of A2 B1 that is possible, number of pairs of A2 comma B1 that is possible is 0 plus 1 plus 2 plus 3 plus 4. That is equal to 3 plus 3 6. That is 10 choices, 10 pairs. Okay. So therefore, the number of elements in the set S, therefore the number of elements in the set S, in the set R, that will be 10 into 16. That is equal to 160. So option D is the correct answer. Then here it is told an organization uh, awarded 48 medals in event A, 25 in event B, and 18 in event C. If these medals went to total 60 men and only 5 men got medals in all the 3 events, then how many received medals in exactly 2 of the 3 events? Okay. So these medals went to a total of 60 men. So therefore we have set A, set B, and set C, A, B, and C. So let's say this region is A, this region is B, let's say this region is C, this region is B, this region is C, and this region is X, this is Y, this is Z, and this is P, suppose. So therefore, we have to find how many received medals in exactly 2 events. It means we have to find out the value of X plus Y plus Z. And P equals to 5. Since here it is told only 5 men got medals in all the 3 events. And A plus B plus C plus X plus Y plus Z plus P, that is equal to 48. No, that is equal to 60. And 48 medals awarded in event A. Means a plus x plus y plus p, that is equal to 48, and 25 in event b. So it means x plus p plus b plus z, that is equal to 25, and 18 in event c. So it means y plus p plus z plus c, that is equal to 18. How many received medals in exactly two of the three events? So now if you add these three, then we will get a plus b plus c plus x is coming two times, y is coming two times, z is coming two times. So it is 2 into x plus y plus z plus 3p, that is equal to 60. No, that is equal to 48 plus 25 plus 18. So now, therefore, if we subtract this first equation from second equation, so if you do second minus first, then we will get um, x plus y plus z plus 2p. 3p, since a plus b plus c will get cancelled, and 3p minus p is 2p. So that will be 48 plus 25 plus 18 minus 60. So then, and p is 5, so 2p is 10. So x plus y plus z, that will be equal to 48 plus 25 plus 18 minus 60 minus 10. So this will be equal to uh, is 73 minus 60 plus 18 minus 10, that is 8. So this is 13 plus 8, that is equal to 21. So it means 21 of them received medals in exactly two of the three events. So option C is the correct answer. Then here it is told, let A be the set 2, 3, 4, and B is the set 8, 9, 12. The number of elements in the relation R is equal to A1. Okay. When A1 divides B2 and A2 divides B1. So here it means it is told A1 divides. So here A1 B1, that is related to A2 comma B2 if A1 divides B2 and A2 divides B1. So A1 and A2 are in set A. From set A1 and A2 belong to set A, and B1 and B2 belong to set B. So then you have to find out the number of elements in the relation R. So therefore A1 comma B2, that will belong to the set. So A1 should divide B2, so it means it can be 2 comma 8, since 2 divides 8 and 2 divides 12 also. So 2 comma 12 and 3 comma 9 and 3 comma 12, and similarly 4 comma 8 and 4 comma 12. So therefore it gives 6 pairs of A1 comma B2. Similarly A2 should divide B1. Similarly A2 comma B2, A2 comma B1 also will belong to the same set as uh, same set as above. So therefore we will have six pairs of A2 comma A2 comma B1 also. Now therefore the number of elements in the number of elements in the relation R, that will be equal to 6 into 6. Since why we have six pairs of A1 B2 and six pairs of A2 B1. So therefore 6 into 6, that will be 36 elements. So option C is the correct answer. And here it is told A is a set containing the elements 1, 2, 3, 4, 5, 6, 7. Then R is a relation which contains the order pair x comma y, such that x comma y should belong to the set A and x plus y should be equal to 7. X plus y should be okay. So here x and y should belong to A. X plus y equals 7. So therefore x comma y can belong to, so or it means the relation R can be equal to, so y equals to 7 minus x. So it means it can be 1 comma 6, 2 comma 5, and then 3 comma 4, 4 comma 3, and 5 comma 2, and 6 comma 1. So it means it can have these 6 elements. And then so it is not reflexive. It is not, R is not reflexive. Since why? Since 1 comma 1 is not there. 1 comma 1 or 2 comma 2 does not belong to the relation R. And R is obviously symmetric. R is symmetric. Since x comma y belongs to R also implies that y comma x also belongs to R. And R is not, okay, R is not transitive. Since y 3 comma 4 is there, R is not transitive also. Not transitive also. Since why? Since here we can see that 2 comma 5 is there and 5 comma 2 also belongs to the relation R, but 2 comma 2 does not belong to the relation R. So it is neither symmetric, it is neither reflexive nor transitive, but it is symmetric. It is symmetric, but neither reflexive nor transitive. So option C is the correct answer. Then here it is told P of S denote the power set of S. P of S is the, means it is a set of all subsets. Set of all subsets of the set S, where S is given as 1, 2, 3 till 10. And then define the relations R1 and R2 on P of S such that A is related, the set A is related to B if A intersection B complement union B intersection A complement, that is equal to 5. And A is related to B under the relation R2 if A union B complement, that is equal to B union A complement for all A comma B belongs to the the power set of S. Okay. So then we have to find. Okay. So now R1, now A intersection A complement, that is obviously equal to phi. So therefore R1 is reflexive. R1 is obviously reflexive, since why A intersection A complement union A intersection A complement, that will be obviously phi, since phi intersection phi union phi is phi. And also A is related to B under the relation R1 also implies that B is related to A under the relation R1. Since why? Since A intersection B complement union B intersection A complement, if that is phi, then we can also say that B intersection A complement union A intersection B complement, that will be also phi. So therefore R is reflexive and R is symmetric also. It's symmetric. Now for transitive, we should have now A intersection B complement, A intersection B complement union A complement intersection B, that is equal to phi. And also if B intersection C complement union C complement intersection uh, union B complement intersection C, that is equal to phi. So this means that A should be equal to B, and this also means B should be equal to C. So therefore A should be equal to C, and which also means that A intersection C complement, that should be also union A complement intersection C, that will be also equal to phi. So therefore A is the relation. So it means that if A is related to B under the relation R1 and B is related to C under the relation R1, then this implies that A is also related to C under the relation R1. So it means that R1 is transitive also. R1 is transitive. So it means that R1 is reflexive also, R1 is symmetric also. So it means that R1 is an equivalence relation. R1 is an equivalence relation. So R1 is equivalence. Now for R2, we have to check that now R2 equals to, so for in the relation R2, R1 is an equivalence relation. And for R2, it is told that A is related to B under the relation R2 if A union B complement, that is equal to A complement union B. So now A union A complement, that will be obviously equal to the universal set. So it means the relation R2 is obviously reflexive, and also A union B complement is same as A complement union B. If this happens, then also we can say that that B union A complement, that will be also equal to B complement union A. So therefore R2 is symmetric also. R2 is symmetric also. Now for transitive, we have to check. For transitive, if if let's say A union B complement, that is equal to A complement union B, and also B union C complement, that is equal to B complement union C. Okay. So now suppose if we take set A, set B, and if we take one element A here and one element C here and one element D here and one element B here. Now, therefore, A union B complement, that will be equal to A, and A complement union B, that will be equal to B. So if they are same, it means that A should be equal to B. So it means the set A should be equal to set B. And also similarly, we can say that B union C complement intersects equal to B complement union C also implies that A also means that B equal to C. So it means that A equal to B and B equal to C, it means A should be equal to C, which also means that A union C complement, that should be equal to A complement union C. So R2 also is an equivalence relation. R2 also is an equivalence relation. So it means that both R1 and R2 are equivalence relations. Both R1 and R2 are equivalence, sorry, both R1 and R2 are equivalence relations. So option C is the correct answer. So here it is told that let R be a relation on the set R, where this R is the set of all uh, real numbers, and this R is the name of the relation. So R given by R equals to A comma B, where 3A minus 3B plus root 7 is an irrational number, then R is how much? R is what? So now for reflexive, so we have to find if this relation R is reflective, symmetric, or transitive or not. So for reflexive, we should have that if A comma means A comma A should belong to the relation R. So now A comma A, it means it should be 3A minus 3A plus root 7. So which is equal to root 7, and which is a rational, which is an uh, irrational number. So hence the relation R is a reflexive relation. R is a reflexive relation. Then it is told that for symmetric, we should have that if a comma b uh, belongs to the relation R, then it implies that b comma a also should belong to the relation R. If a comma b belong to R, then b comma a also should belong to the relation R. So now, therefore, uh, so if let's say 3a minus 3b plus root 7 is irrational, then 3b minus 3a plus root 7 may not be irrational, may not be rational also. Since why? For example, suppose if you take 3a minus 3b equals to root 7, then 3a minus 3b plus root 7, that will be equal to 2 root 7, which is irrational, which is irrational. Uh, uh, but 3b minus 3a plus root 7, so that will be minus 3a minus 3b plus root 7, or I can say then that will be minus root 7 plus root 7, which is equal to 0. And we know that 0 is a rational number. So 0, which is not irrational. It is not irrational. So it means the relation R is not symmetric, is not a symmetric relation. Now we have to show that if it is transitive or not. So for transitive we should have that if a comma b belongs to the relation R and b comma c also belongs to the relation R, then this implies that a comma c also should belong to the relation R. Then only I will tell that a R is a symmetric, R is a transitive relation. So now if suppose 3a minus 3b plus root 7 is irrational, and also 3b minus 3c plus root 7 is also irrational, then 3a minus 3c plus root 7 may not be irrational, may not be irrational also. Since why? For example, suppose we take a as 0 and b as minus root 7 and c as root 7 by 3. So then 3a minus 3b plus root 7, that will be equal to 3 root 7 plus root 7, that is 4 root 7, which is irrational, and also 3b minus 3c, so 3b minus 3c is root 7 by 3 plus root 7, that is equal to minus 3 root 7, which are irrational numbers, which are irrational. 4 root 7 is also irrational, and minus 3 root 7 is also irrational. Now if you take 3a minus 3c plus root 7, that will be equal to 3 into 0 minus 3 into root 7 by 3 plus root 7. So that will be equal to 0, which is not irrational. Since why? As we know, 0 is a rational number. So which is not irrational, not irrational. So it means that uh, R is not transitive. The relation R is not transitive. So it means that it is neither transitive nor symmetric, but it is reflexive. So it is reflexive, but neither symmetric nor transitive. So option D is the correct answer. Then here it is told among the relations S equals to A comma B, where A comma B belongs to R minus 0, 2 plus A by B is greater than 0. And so S is a relation where A and B uh, belongs to the set of all non-zero real numbers, and T is the set of all ordered pairs A comma B such that A comma B, A and B are real numbers, and A square minus B square belongs to Z. It means that A square minus B square should be an in integer. Now here you can see for the relation T, for the relation T we have A square minus B square should be equal to an integer. So let's call this as I. So therefore B square minus A square, B square minus A square, that also should be minus of I. So it is also an integer only. So therefore if A comma B belongs to the relation T, then B comma A also will belong to the relation T. So I can say T is symmetric relation. So we have to find which one is symmetric and which one is transitive. Okay, since so it means reflexive, we don't have to check. So now for S, 2 plus A by B, that should be greater than 0. So it means A by B, that should be greater than minus 2. It means B by A, that should be less than minus half. B by A belongs to minus half. So now if let's say A comma B belongs to S, then it means that A by B, that should be, or I can say B by A, that will be less than minus half. And if B comma A also belongs to the set S, then we can say that A by B, that should means I can say that 2 plus B by A, that should be greater than 0. It means that B by A, that should be greater than minus 2. It means A by B, that will be okay, B by A, that should be greater than minus 2. And here it is told B by A should be less than minus half. So it means that here this condition is not satisfied. Let's say we take A comma B, which is suppose 1 comma, that is let's say we take minus 2 comma 1. So then it means that minus 2 by or 1 by minus 2, let's say this we take 3, suppose minus 2 comma 3, then 3 by minus 2, that is equal to minus 3 by 2, which is obviously less than minus half. So this minus 2 comma 3 will belong to the set S, but 3 comma minus 2 will not belong to the set S. Since why? Since here minus 2 by 3, okay, minus 2 by 3, okay, let's say we take, minus 2 comma 10, suppose. Then it means 10 by minus 2, then 10 by minus 2, that is minus 5, and that is obviously less than minus half. So minus 2 comma 10 will belong to the set S, and 10 comma minus 2, if that belongs to the set S, then minus 2 by 10, that is b by a, that is equal to minus 1 by 5, which is more than minus half. So it means this does not belong to the set S. Since why? Since minus 1 by 5 is more than minus 2. So it means the uh, re relation S is not symmetric. So relation S is not symmetric. So it means that T is symmetric, but S is not symmetric. So option D is the correct answer. Then here it is told, let R be a relation on the set n cross n defined by A comma B is related to C comma D if and only if AD into B minus C, that is equal to BC into A minus D. Then R is, yeah. So for, so we have to check if it is reflexive, symmetric, or transitive. So now if A comma B is related to A comma B, then only we can tell that it is reflexive. Then only R is reflexive. Now, if A comma B is related to B comma B, it means that AD, that is AB into B minus A, AB into B minus A, this is the left hand side, and the right hand side, that is equal to BC into A minus D. So that is BA into BA into A minus B, BA into A minus B. So this is obviously, they are not same. Since why? The right hand side is the negative of the left hand side, so they are not said, they are not same. So therefore the relation R is not reflexive. It is not reflexive. And for symmetric, we have to do, if A comma B is related to C comma D, then it also implies that C comma D should be related to A comma B. So therefore it means that if AD into B minus C, that is equal to BC BC into A minus D, BC into A minus D, then will this be true or not? That is CB into D minus A, that is it equal to, is it, then is this equal to this BC, that is BC, that is DA into A minus D, that is C minus B. So are they same or not? So they will not always be the same. Okay. So is this equal or not, that we have to check. So here AD into B minus C, that is equal to BC into A minus D. So if we take, if we multiply with -1 on both sides, then we will get that DA into C minus B, that will be equal to CB into D minus A. So obviously they will be same. So therefore the relation R is symmetric relation. It is symmetric. And we have to check for transitive. Now for transitive is that if A comma B so is related to C comma D and C comma D is related to E comma F, then A comma B also should be related to E comma F. So let's check if this is true or not. Now let us take uh, the numbers 2 and 3. 2 comma 3 is related to 3 comma 2. Since why? Since we can say that AD into B minus C, AD into B minus C, that is equal to BC into D minus A, BC into A minus D, 2 minus 2. So which is equal to 0. So it means these two are related. And also 3 comma 2 is also related to 5 comma 30. 3 comma 2 is related to 5 comma 30. Since why? Since AD into B minus C, which is equal to AD into B minus C, which is equal to 90 into minus 3, that is minus 270, and A and BC into A minus D. So that is equal to 10 into minus 27, which is minus 270. So these two are related, but 2 comma 3 related is not related to 5 comma 30. Is not related to the order pair 5 comma 30. Since why? Since AD into B minus C, so that will be equal to 60 into minus 2, which is minus 120, and BC into A minus D, BC into A minus D. So this will be equal to 15 into minus 28, which is equal to 15, okay, which is equal to, I can say, minus 30 into 14, which is equal to 14 3 42. So this is minus 400 20. So it means they are not same. So hence we can say that hence the relation R is not transitive. So R is not transitive. So it means that the relation R is symmetric but neither reflexive nor transitive. It is symmetric but neither reflexive nor transitive. So option D is the correct answer. Then here it is told that the minimum number of elements that must be added to the relation R, which is A comma B and comma B comma C on the set comma C, B comma C on the set ABC, so that it becomes, yeah, so that R is symmetric and transitive. R is symmetric and transitive. So that we have to find out. So how many elements should be added on, and R is a relation on this set. Okay. So therefore R, we have A comma B and B comma C. Now since it has to be symmetric, so B comma A also should be there and C comma B also should be there, and A comma B is there and B comma A is there, so A comma A also should be there since it has to be transitive also. So A comma A also should be there, and since B comma A and A comma B is there, so B comma B also should be there, and B comma C is there, C comma B is there, so B comma B is also there, and C comma B is there and B comma C is there, so C comma C also should be there. So it means that these 5 elements we have to add. We have to add 5 elements, and then it is A comma C. Okay, yeah. So here A comma B is there, B comma C is there, so A comma C also should be there since it has to be transitive also. A comma C also should be there. Now since uh, B comma A is there, okay, and C comma A also should be there since C comma B is there and B comma A is there, so C comma A also should be there. So it means these elements you have to add. It means 4 plus 3, 7 elements. So 7 elements should be added to the relation R. So option A is the correct answer. Then here it is told that let R be a relation defined on the set N. R is a subset of N cross N. It is defined on the set N. It is defined as A is related to B if 2A plus 3B is a multiple of 5. 2A and 3B is a multiple. 2A plus 3B is a multiple of 5. Then R is. Now we have to find if it is reflexive, symmetric, or transitive or not. So now for reflexive, we have to check if A is related to A or not. So if A is related to A, then we can say that 2A plus 3A. So that will be obviously 5A, and which should be obviously a multiple of 5, which is a multiple of 5, obviously. For all A belongs to N. And then for reflexive, yeah, and for symmetric we should have, for symmetric we should have that that if A is related to B, then B also should be related to A for all A comma B belongs to N. Then only we can tell that R is a symmetric relation. So now, which will not be true, since why? If suppose, for example, if you take um, A as 1 and B as okay, so A as 2, 4, 12, 15. So let's say we take okay, okay. So now if 2A plus 3B, that is equal to 5M for some integer M, means for some natural number M. Okay. So it means that 2A plus 3B is a multiple of 5. Now then 2B plus 3A, 2B plus 3A will be, it will be a multiple of 5 or not, that you have to check. Now 2B plus 3A, I can say this will be equal to 5B minus 2B plus 5A minus 2A. Now this is 5B minus 3B plus 5A minus 2A. So it means this will be 5 into A plus B minus of 2A plus 3B. Now 2A plus 3B is 5M. So it means this will come 5 into A plus B minus 5M. So which will be obviously a multiple of 5, which is a multiple of 5, which is a multiple of 5. So hence the relation R is a symmetric relation. R is a symmetric relation. And then for transitive we need to have that if A comma B, if A is related to B and if B is related to C, then this implies that A should be also related to C for all A, B, and C belongs to the set N. Then only I can say R is a transitive relation. Now if we say that 2A plus 3B equals to suppose 5M and 2B plus 3C, that is equal to 5N for some natural numbers, M and N, then we can say that 2A plus 3B is also a multiple of 5 and 2B plus 3C is also a multiple of 5. Now 2A plus 3C, that will be how much? 2A plus 3C, 2A plus 3C, that you can write it as, this will be 2A plus 3B plus 2A plus 3B plus 2B plus 3C. minus 5b. Since why here 5b will come if we add them, and 2a plus 3c is already there. So this we can write, this will be 5m plus 5n minus 5b. So which is equal to 5 into m plus n minus b. So m plus n minus b is also a natural number. So therefore 2a plus 3c is also divisible by, is, or I can say is also a multiple of 5. So it means that R is transitive also. R is transitive relation also. So it means R is transitive, R is symmetric, and R is reflexive also. So R is reflexive also. So hence R is an equivalence relation. R is an equivalence relation. So option A is the correct answer. Then here it is told that the relation R equals to it it contains all those ordered pairs a comma b such that the greatest common divisor of a comma b is equal to 1. It means that a and b should be co-prime integers. So the greatest common divisor or the highest common factor of a and b is 1, and 2a is not equal to b. Here 2a is not equal to b, where a and b are some integers. Then we have to find if R is reflexive, symmetric, or transitive. So for reflexive, we should have that a comma a should belong to the relation R for all a belongs to z. So now the greatest common divisor of a comma a, that is equal to a, not 1. So it is applicable only when a and b both are 1. And 2a is not equal to a, that is true, but the greatest common divisor is not equal to 1. So therefore R is not reflexive. R is not a reflexive relation. And then for symmetric, we have to see that if a comma b belongs to the relation R, then this implies that b comma a also should belong to the same relation R. Now now if 2a is not equal to b, and the greatest common divisor of a comma b equals to 1, then 2b 2b also, okay, no, a, it, here I should write for all a comma b belongs to z. Okay, so now suppose here we take here 2b also will not be equal to a, and greatest common divisor of a and b also, b and a will be 1, but 2b will not be equal to a. For example, suppose we take 2 and 1. Now the greatest common divisor of 2 and 1, that is equal to 1, and 2a, that is 4. 4 is not equal to 1, but greatest common divisor of 1 and 2, that is equal to 1, but uh, 2b, that is, or I can say 2a, that is 2 into 1, that is equal to 2, and not uh, so 2 is equal to 2. So here 2a is coming equal to b. So hence R is not symmetric. R is not symmetric relation. And then for transitive, we should have, for transitive, if a comma b and c comma d belong to the relation R, then this implies that a comma d also should belong to the relation R for all a, for all, okay, for all a b c d. No, no, sorry, sorry, sorry. Yeah, b comma c, I should tell. If a comma b belong to the relation R and b comma c also belongs to the relation R, then a comma c also should belong to the relation R for all b, a b c belongs to z. So now a comma b, if it is belonging to R, so now we can take some example, that is, let's say we take a as 14, b as 19, and c as 21. So now then the greatest common divisor of 14 and 19, that is equal to 1, and 2a, that is 2 into 14, that is not equal to 19. Okay. And for b and c, and then greatest common divisor of 19 and 21, that is equal to, that is equal to 1, and also 2 into 19, that is not equal to 21. uh, uh, but here if we take a and c, then the greatest common divisor of 14 and 21, that is 7, and 2 into 14, that is not equal to 21, but the greatest common divisor is not 1. So it means that therefore this a and c will not belong to R for all a b c belongs to z. So it means that R is not transitive. The relation R is not transitive. So hence it means that therefore R is not reflexive and not transitive. R is not symmetric also. So therefore R is neither symmetric nor transitive. So option D is the correct answer. And it is not reflexive also. Then here it is told the number of elements in the set, the number of elements in the set n belongs to n such that n is greater than or equal to 10 but less than or equal to 100, and 3 power n minus 3 is a multiple of 7. 3 power n minus 3 is a multiple of 7. 3 power n minus 3 is a multiple of 7. So now n should go from 10 to 100. Okay. So here, if we take n as 1, suppose we take n as 1, then this 3 power n, 3 power 1, if we divide it by 7, then the remainder will be 3. So it means we have to apply the mod function. So 3 mod 7, that is equal to 3. Since why? When 3 is divided by 7, the remainder is 3. Similarly, if we take n equals to 2, then 3 power n, that is 3 square, its mod 7, that will be equal to 2. And similarly, n equal to, if it is 3, then 3 power 3, if we do mod 7, then the remainder will be 6. Then if n is equal to 4, then 3 power 4, that is 81. So 81 mod 7, that will be equal to 4. Since why 7, I just 6, 7, 8, 7 on the 7, 7, 11 is 77. Okay. Then if n equals to 5, then 3 power 5, that is 243. 243 divided by 7, 7 3 is 21, 33. So 7, 7 4 is 28. So it is 5. So 3 power 5 mod 7, that is equal to 5. Then n equal to 6, then 3 power 6, that is equal to 729. So then that divided by 7, that is 7 on the 7, 7 2, then 0, 7 4 is 28. So it means the remainder is 1. So it means, and here again, if we do 3 power 7, then again, if n equal to 7, then again a remainder will come from 3. Since why, if n equal to 7, then 3 power 7, that is 3 9s are 27. No, yeah, 3 9s are 27, and 2 to the 6, 8. 7 is 21, 2187. Then this divided by 7, 7 3s are 21, then 7 1s are 7, 17, 7 2s are 14. So the remainder is 3. So mod 7, the remainder is again 3. So it means here we have a cycle of 6. Cycle of 6. Now if we do 3 power n minus 1, then here also, if we take n equal to 1, then 3 power 0 mod 7, that is 1. The remainder is 1. Then if you take n equal to 2, then 3 power 1 mod 7, that is 3. Then again 3, n equal to 3, then this is 3 power 2, that mod 7, that is equal to 2. Then n equal to 4, then 3 power 3 mod 7, that is equal to 6. And n equal to 5, then 3 power 4 mod 7, that is equal to 81. So that is, remainder is 4. So n equal to 6, then 3 power 5 mod 7, that is equal to 5. N equal to 7, and 3 power 6 mod 7, that is equal to 1. So here also there is a cycle of 6, but it is shifted. Now then so 3 power n minus 3, that we can, if we take 3 as common, then we can write 3 power n minus 1 minus 1. So here so here we can see that 3 power 6, that is coming some 7 m plus 1. It means here the remainder is 7 when we divide by 7. So it means that this n minus 1, that should be a multiple of 6. Minus 1, that should be a multiple of 6. Then only this thing will come 3 into 7m minus plus 1 minus 1. Then it will be a multiple of 7. So it means that n minus 1, that should be a multiple of 6, or n should be of the form 6 and 6 6q plus 1. It means it should be a multiple of 6 plus 1. So in this form n should be. So n is going from 10 to 100. So whenever n is of this form, then only we can tell that 3 power n minus 3 is a multiple of 7. So therefore from 10 to 100, you can say 6 1 is 6, 6 plus 1, that is 7. 6 is 12, 12 plus 1, that is 13. So from 10 to 100, we have to check which numbers are of this form, 6q plus 1. So 1 is 13, 6 to the 12 plus 1, then 6 is 18 plus 1, that is 19, plus 6, that is 25, plus 6, that is 31, plus 6, that is 37, plus 6, that is 43, plus 6, that is, so till 100 we have to go. So it means if we divide 100 by 6, then we'll get 6 ones are 6, 40, then 6 8s are 40, 6 7s are 42, 6 7s are 42, 6 6 are 36, so 4. So it means that 96 is a multiple of 6. So 97 we should take, which is of the form 6 into 16 plus 1. So 13 to 97 here. So it is an AP with common difference 6, with common difference equal to 6. So it is an AP with common difference 6, and the first term is 13 and the last term is 97. So how many terms are there that we have to find out? So those many elements will be there in the set. So 97 is equal to a plus k minus 1 into d. D is 6. So k will be equal to 97 minus 13 by 6 plus 1. So that will be 84 by 6 plus 1. So this is 6 1s are 6, 6 4s are 24, plus 1, that is 15 elements. So there are 15 elements in the set. There are 15 elements in the set. So the answer will be 15. Okay. So hope all of you understood all these solutions. Still any doubts if you have, please write that in the comments section. We shall obviously clarify them in the subsequent videos. And please install our Sapience Education application, where we shall upload some important uh, questions based on the previous year JEE Mains exam on every chapter of maths, which shall be obviously helpful for your exam. So thank you everyone. Bye.